Hello everyone, my name is Hashmi Kaur and this is my demonstration for task 3.3, a distinction level task of embedded system development. The goal is to build an IoT system that communicates with Arduino 933 IoT using the MQTT publish subscribe protocol. My system is designed to detect a physical way using a sensor, publish a message to the same channel to receive a message, and react by flashing an LED. This creates a full circle communication loop and demonstrates the foundation pattern for the IoT. So let's look at my hardware setup. Here it is. Our primary sensor is ultrasonic sensor. It acts as the system's eyes, measuring distance to detect when a hand wave is in front of it. And for our output, we have a simple LED right here on a breadboard that blinks when it detects an wave. This provides a physical notification confirming when a message has been received. The components are connected to the Arduino's digital pins for control and communication. Let me show it to you. This is my Arduino 933 IoT. To understand how this works, we need to understand the publish-subscribe model. Instead of devices talking directly to each other, they communicate through a central hub called an MQTT broker. For this project, I am using secure HiveMQ Cloud Broker. In this architecture, my Arduino acts as a publisher. When the ultrasonic sensor detects a wave, the Arduino publishes a message to the specific channel or the topic named SIT210/wave. My Arduino is also a subscriber. It is actually listening to the exact same topic. The broker is the middleman. It receives the message from the publisher and immediately forwards it to the subscribed devices. The power of the system is that it's decoupled. The publisher doesn't know who is listening, and the subscriber doesn't know who sent the message. They only need to know the broker's address, the topic name. This makes the system incredibly scalable and flexible. Now, let's discuss how the software achieves this, focusing on the main functional blocks of code. Let me show it. The setup function is responsible for the initialization. Its first job is to connect the Arduino to the physical world by establishing the Wi-Fi connection right here by giving the Wi-Fi details. Its second and more important job is to connect to the digital world by authenticating and connecting to the MQTT broker. Once connected, it immediately subscribes to our SIT210 wave topic, so it's ready to listen. The loop function is active, sensing the part of the program. It continuously holds the ultrasonic sensor to get a distance reading. I have programmed a simple condition. If an object comes within 100 centimeters, it triggers the publishing event. The on message received function is the most interesting part. Well, this is a callback function. It isn't run in the main loop. It is only triggered by the MQTT library when a new message arrives. Its sole purpose is to handle incoming data. In my code, it puts some message payload to the serial monitor and then calls a logic to flash the LED 3 times. Okay, so now let's see it all in live action. As on my screen, you can see that my HiveMQ cloud is open, the cloud is open, and my Arduino serial monitor is also opened. So now let's start by uploading our code to the IDE. It's uploading and disconnecting to the Wi-Fi. And now let's wave at it. Like, this is my sensor, as you can see right here. This is my sensor, and when I am near it, it is the wave is received, and wave detected, and the message received is the wave is coming. This confirms that my system is working, and the LED blinks when I wave at it. When I wave at it, the LED blinks. If it's not clear, visible clear to the lightings in my room, but when I wave at it, the LED is blinking. And okay, if we look at the high voltage line, the exact same messages appear here. Let me show it to you. This confirms the Arduino is successful publishing the message to the cloud, and then it is received as a subscriber as well. Now I'll use the web client to act as a buddy, sending a wave back. I have sent the messages from the web client. As you can see, the Arduino's LED flashed, and the message will appear on our serial monitor as well. This proves the system is fully functional and can receive messages from the MQTT enabled device in the world. Finally, for the distribution task, the requirement was to modify the code to handle a path message differently from a wave. The way to implement this is written on the message received function, which is right here. I would introduce conditional logic like an if-else statement to inspect the component of the message, and if the if statement would check if the message is the standard wave message, and if so, it would run the 3-line code we have already seen. The else if condition would check if the message is bad. If it is, it would call a different function to flash the LED in a unique pattern, for example a quick double flash. And this approach makes the device much smarter around to perform different actions based on the specific commands it receives, which is equal such in advance IO systems. In conclusion, this project successfully demonstrates a reliable real-time messaging system using an Arduino and MQTT protocol. It efficiently showcases the power of publish subscribe model for creating decoupled and scalable IoT solutions. Thank you so much for watching.